Today's topic is just frequently asked questions and issues that we often get at Bonitron. I guess this one's going to be more open-ended. I mean, you're free to jump in with any questions and any issues that you've seen in the past or anything like that. Um, Basically, just be going over a few of our common products and just as you know what I've seen as just being the troubleshooting and tech support here at Bonitron. Um, just issues that often come up with certain of our product lines. Here, the screen just shows a few of the products we'll be talking about today. If there's any other products you'd like me to talk about, I'd be happy to. Um, but I just wouldn't have anything prepared, so we'd probably have to go online and just look at the manuals and go over it that way. So yeah, let's get started. So basically, I'm the tech support here. My name's Tim Watkins. Um, so basically, I will get a call or just an email or something, and basically just have to respond to the very, very usual question of, "Hey, my Bonitron doesn't work." So basically, you just start with the basic information, serial number, model number of the unit is very, very helpful. The next most helpful thing is, of course, the system drawing. Um, Basically, just it helps so much just being able to see how our units are connected up to the drive and everything else. Um, so in this case, a picture is just literally worth 1,000 words, um, and it just helps us start troubleshooting. Even though most of our units just require very few connections with the drive, it's still worth it just having that drawing, just so that myself and the customer are just all on the same page. So this is a very quick little basically standard operating procedure for when I get a tech support call. So first off, I collect their info, just to understand who I'm talking to. Um, you know, is it the end user? Is it a distributor? And that basically just lets me know, I guess, priority level of how much the customer's down or what sort of situation it is. And I just need to collect info about the unit, basically details of the problem and system. Um, Either walk them through the manual or just use my experience. And hopefully the goal is just getting them up and running as quickly as possible, whether it's an new installation or just something that just stopped working. Or if worst comes to worst, get the unit repaired or recommend a replacement. So part of what I do is track the issues. This is a database that I've put together and created, basically trying to define what products have certain issues, what products don't work well with certain drives, and just trying to get an overview of what might be occurring and what issues Bonitron might have. And this is just basically just trying to create an increased quality of our product, as well as trying to pass that along to the customer in terms of satisfaction with our product and just confidence that Bonitron knows what they're doing, our designs are good and solid, and that we'll just continue to support them. So, and plus this also serves to help me because my memory is finite and I can't remember things from a year ago and all the details. So tracking is a big part of what I do. So just moving on to specific questions and specific issues. This is our 3452. It's our most common braking transistor, braking chopper. It basically functions as a shunt for the VFD to place energy into a resistor and burn it up as heat, rather than have a drive fault out and overvoltage. So the 3452 has a variety of control boards that are offered. The very most basic ones are the A control board and the R5 control board. And these have very limited statuses which they output, mainly just a ready output. By far, the most common question I get on these is basically when they go to start it up and nothing happens and the drive faults out. Typically this occurs because the unit has not been set as a master for standalone operation. The reason we don't automatically ship them as master units is because if they were to place two or more masters together on a common bus, then we just can't predict their interaction. The interaction will be chaotic, and one M3452 might end up destroying the other, basically because they can get into a fault state of basically rapid switching. So that's why if customers order two or more units of M3452s, they're all set for slave operation. The customer can then modify these to either be master or slave by setting these jumpers J7 and J8 on this board to the position L for master operation. If they want slave operation, it should be both in the R position. So the next slide is actually a picture of this, a picture of the actual board. So yeah, this is jumper J7. I believe I have this marked incorrectly. J7 should be the lower one and J8 the higher one. But they're both in the L position. So this unit is set up for master operation or standalone operation. Oftentimes when I tell customers to do this, they will ask me right away what these three jumpers are down here. J4, J5, and J6. These are factory set. Basically, these are the what control the input voltage for the board, and these should not be messed around with just willy-nilly. The reason for that is while you could change this and the board could think it should be getting 240 instead of 115, the control transformer is actually what controls it. This just controls the logic. So customers should not mess with these jumpers, but only change these jumpers as required for master and slave operations for the A and R5 control boards. So the M3452 also has the R7 and the R7 EIP control boards. And basically these have more functionality. You can find out more faults, more accurately understand what the unit is doing, and also being able to control this remotely from a panel, either to remotely enable it or remotely change it if it's master or slave. This is the detail of the actual physical unit. Underneath the lower panel, which I took off for this picture, we have a small little cheat sheet that basically describes where the enable is, where the control ready signal output signal is, and the power stage ready output signal is. This is very small, almost a code, so it's really best just for the customer just to look at the manual. This has a better description. In the next slide, I actually just did a screen grab of the actual drawing in the manual. So the R7 board is actually a board, the lower board, and the R7E is a little addition that provides more outputs as far as what sort of faults or the actual status of the unit. And the R7E board sits on top of just the R7 board. So where it describes this dotted region as being optional, this is the E option of the R7. So if you're just going to get a plain R7, this dotted area would not be present on that board. So TB1, this is the control power. This will be how you power the 3452 and its logic. In order to get this unit to operate properly, the question I get most often is about the enable. It's just very common. I mean, they get power to the unit and they expect it to work straight out of the box, but our units do not become pre-enabled or with the jumpers already installed. A lot of our customers want to be able to remotely control these and bring these on and off a common bus, just depending upon their setup. So the enable is controlled on terminal strip 2, this terminal strip, terminals 3 and 4. The unit must be enabled for it to function. The control ready output, this basically is a dry contactor. It's a normally open but held closed contact. So that means whenever there's a fault or the unit's not enabled, the control ready contact will open. There's also the power stage ready. The reason we have two separate ready outputs is that customers may want to know that their unit's functioning without it being enabled. So that's why we have the power stage ready. So the power stage ready basically tells that the IGBT and all the other power stages are fine and functioning well. If you want to create a single ready output just from both of these, you can place the control ready and the power stage ready contacts in series and just create a single contact with your voltage coming into 1, coming out of 2, going into 5 and then coming out of 6. The only thing that customers need to realize is that there's a small voltage drop across each of these contacts. So if your PLC is not configured correctly, it could show up as being open all the time when it's not, and the contacts are actually closed. So that's been a very rare occurrence. I believe it's only happened 2 or 3 times I can recall when customers trying to set it up. But once they realize that, they can just retool their PLC or pump in a slightly higher voltage going across these contacts, and that solves the issue. Likewise, if this can be either set for a master or slave, in most cases people are using this as a standalone unit, so it needs to be set for a master. And the easiest way to do that is just place a jumper here. If there's no jumper or no switch here, then the unit will just always be a slave, and we'll be following the master. So this basically concludes a lot of my common issues with the 3452. The M3452 is a pretty solid unit. It doesn't really have that many issues. It's been in service for 10 to 20 years, so there's a lot of expertise out there in terms of the people installing it. And really the questions only come up from people who've never used these units before. Okay, I'm just going to move on to our next breaking chopper. Oh, I apologize, there's a little bit more. So the next question we do get is about the M3452, is the length of the DC bus. Our manual basically says to only have a maximum length on the DC bus of 10 feet. We put this in there because our goal is to limit voltage ringing. In long DC buses, this causes a little bit of parasitic inductance, and as a result, when there's switching on and off, there can be small voltage spikes at the end, and it's just not good for equipment over time. And it's certainly not good for the M3452. So while we don't have like a hard limit of, if it's 51 feet, then the unit is definitely going to destroy itself, we just can't test that and test it in every situation. So we like the customers to limit to 10 feet. However, the issue is that, it's often not possible for the customer to limit it to just 10 feet in length. Cabinets are laid out, very differently from location to location. Common bus systems often have very long DC bus lengths, just because you're trying to link several drives and several braking systems together. So often those are well over 10 feet. And likewise, if you're trying to retrofit an existing cabinet by mounting a 3452 on a wall next to the cabinet or something, it's really hard to get that DC bus length. So there are ways to limit that sort of voltage ringing. Using bus bars will help instead of using wiring. Some drive manufacturers in their common bus manuals recommend twisting of the DC bus links. Before you do that, I do recommend consulting your drive manufacturer's literature or just calling their helpline and seeing what their recommendations are. Typically it's about 2 twists per foot if you can. However, once you get to the higher current ratings, it's almost impossible to do that. Okay. So now moving on to our other braking transistor, the M3575T. Basically this one is only powered off of the DC bus, so there's no control power coming in from the AC. So this one will start up once the voltage gets high enough, above 20 volts, 20 to 50 volts on the DC bus, and the little yellow LED will come on the front once it's above 50. So all of our braking transistors, as well as our regens, are all designed to go across the drive capacitor, marked here and here on this diagram. Yeah, we like to be directly across the capacitor wherever possible. Often it's pre-charge resistors and things like that, which are built in, which we can't go against. But we definitely should not be on the line side or the rectifier side of any choke, on any DC link choke inside the drive. Basically, this creates with our choppers. Our choppers have a small little bit of snubber cap going across our transistor. The transistor, the snubber cap plus the inductor creates what's called a boost circuit, and that will basically destroy the chopper. The chopper will enter a mode of rapid switching and basically harm itself. So that's why it's really, really important to be across the DC bus terminals if possible. A lot of drive manufacturers also have braking terminals for their resistors. While it's not necessarily bad for our unit won't function properly, and the drive will basically fault out on overvoltage. So the importance of the 3575T is that it really needs to have capacitance on the DC bus. If you haven't had the chance, I really recommend you read the section 7.3 of the 3575T manual. This has a great page about how and why all our braking transistors. This includes the M3452 and this very small M3675T. Why they all need to have capacitance on the DC bus. The problem with the M3575T is that it doesn't have any control. Once it's connected to the DC bus, it remains connected. So a lot of drives and a lot of rectifiers need to bring their capacitance up from 0 and basically just do a pre-charge. So basically you cannot just have like a simple diode bridge going and feeding into M3575T. A simple diode bridge, an example of that would be our M3713 DM power supply. That DM is basically a simple bridge rectifier, and there's no real capacitance in that unit. And the M3575T will basically harm itself if it's connected to the M3713 DM power supply. As far as being connected directly to drives, the M3575T has no problems because drives have their own, DC bus filter capacitance, and as long as the 3575T is sized to the drive, there's absolutely no issues once the drive brings itself up. The problem with the M3575T is in common bus systems where drives may be brought on or offline, either for maintenance or just for operations. Oh yeah, it's actually a section number. It's section 7.3. I would have to look at the manual right now to basically tell you what page. But that's for the M3575T manual. It's very close to the end. But yeah, it's basically the issues with common busing and the M3575T. You cannot bring the 3575T on and offline, just depending upon the capacitance. For those, I really do recommend using the 3452, where you can either control whether it's enabled either through toggling the enable input or just controlling power to the control board. It's not ideal to bring the 3452 on or offline with the control power because it takes some time to get up and running, about 4 to 7 seconds depending on the unit. But it is a better solution than having the M3575T, and you're trying to bring drives on or offline. Okay. Are there any questions about this so far? Okay, so moving on to the actual braking resistor. There are a lot of questions about the braking resistors that I get, just in terms of troubleshooting and installation. The braking resistor, a lot of customers, once they see that it can handle 200 amps, they want to size the wire to handle 200 amps, full time. And basically I have to convince them that no, you don't really have to do that. Also, the terminals, on most of our smaller resistors won't even be able to handle that. So my example they put up here is the M3775RK-H200A. It is rated for 199 amp peak rating, but it only is going to be rated for 20% duty cycle. So the resistor itself can't even handle wire that's sized for 200 amps. It'd be very tough to connect to our terminals. So what you have to do is just size for 20% of the peak current, because that's the 20% duty cycle, which means you're sizing for about 40 amps continuous. So 6 gauge wire will be fine for the wiring between the M3452 to the braking resistor in this case. The other question that we often get is, how long does the wire have to be between basically the braking transistor to the resistor? And technically there is no limit. You can go miles and miles if you had the money and resources and that much wire. The only thing you'd have to think of is that adding that extra wire will increase the resistance, and increasing the resistance will just lower the current that the resistor will be able to eat up. And other than that, I mean, there's no real issue with having a very long, length of wire between your resistor and transistor. It also allows you to place the resistor outside or just in a separate location if there's like flammable things like sawdust or just vapors, and you just need to isolate it. The other question about resistors are actual temperatures. Resistors do burn off all this energy as heat, and so we do include a temperature switch with our M3775RK and M3775RF resistors, and for those two, those are set for 110 degrees Celsius, and basically it's just a status. Once it gets up to 110, the resistor will open, and the customer can use that open signal to either shut down their drive or just scale back their process if they need it, or just even have a warning light. But the resistor will continue to function up until the point where it just gets too hot and it just basically melts down. The temperature sensor is really just a contactor. The resistor for our M3575R is much lower. It's set for 71 degrees centigrade. I don't know the historical reasons, but I imagine it's just because this particular resistor, the 3575R, is UL rated, and it's very tough to find UL rated braking resistors. And yeah, so it's just really hard to change out any parts once it becomes UL listed. So for the 3575R, it is just going to be the temperature sensor set for 71 degrees centigrade. As for the actual wiring going out to the resistor, we recommend 90 degrees centigrade wiring. Even though the resistor can get much hotter than that, the wires do enter the resistor from the bottom, and we definitely do not recommend running the wire directly above the resistor, as well as they should give the resistor plenty of space around it, up to 2 to 4 inches depending on the size. But yeah, 90 degree rated wire is absolutely fine for basically the operation and running out to the resistor. Alright, so now we'll switch gears a little bit and talk about the line regen. The line regen is a pretty simple unit. It's meant to not really have any field service components. It's meant to be pulled out of the box and just be able to be installed. You attach the 5 wires, 2 going to the drive DC bus and 3 going to the AC line, or 6 wires if you want. You have to include the ground and the grounding. But after you do that, it's really ready to operate. It basically is set for its voltage setting. It measures what the AC line is and then does a calculation and basically will turn on at a certain point above the rectified DC voltage. The only real issue we ever had with these 3645 in terms of installation is basically just the enable input. It used to be that we did not send these out with these units jumpered. We would allow the customer to basically be able to install the jumpers and remotely enable or disable them as they saw fit. However, we kept on getting calls and calls about these, so now all new 3645s will go out with the jumpers already in place. So the jumpers that we send out with the unit are between 1 and 2 and 4 and 5. This connects to the little 24 volts inside, and basically the unit is self-enabled. If the customer does want to control the enable, they can just take the jumper out of 1 and 2 and then install their switch and run that to their PLC, and from there they can enable or disable the M3645 as they see fit. Um, after we just started selling these with the jumpers already installed, this just cut the calls by an amazing amount about the 3645. The only other issue we have with the 3645 is that just older programs, older software would display a certain fault when the units would start up. Basically, would display an overtemperature fault and a pre-charge not complete on startup. This would automatically clear after a few seconds once the M3645 had completed its own pre-charge. However, customers would see this and not really understand and call in with a lot of problems. This was been addressed in the firmware update, but if I do encounter an older unit, this might be a problem, and this is more just a customer communication issue. We do represent in the manual, but basically, if you see an overtemperature fault, the pre-charge not complete fault, it's basically a non-issue. It's just a startup. Does anybody else have any questions about the 3645? Either its operation or stuff that you might have seen or heard about. I don't have too much to add on this. Once again, it's very simple to install, and once it's working, it works great for customers overall. Okay. I'll move on then. Okay. This is
No.
Oh, hello?
Hello?
Hello, I can hear you. Do you have a question?
Yeah, sorry, I was trying to play with my mute.
Okay.
I do have a question. I was just curious how many, for the 3645 and the 3545, do we sell a lot more of one or the other? Just typically, I was just curious.
We typically sell a lot more of the 3645.
Okay.
I think it's just because of the drives, just basically about the power, at the higher power levels. A lot of drive manufacturers don't include a lot of, either regens or braking transistors. Where at the smaller power levels, I believe they tend to. So just the 3645. Plus, it also has a much wider range of current ratings. It extends all the way from 30 amps all the way up to 300 amps. So just by that fact alone, we sell a lot more 3645s.
Okay, that's perfect. Thank you very much.
Okay. All right. All right. So the M3712 is our single phase power supply. Its purpose is basically to basically be an oversized front end for the drive, because if you want to use a three-phase drive on a single phase power, you have to either double the size of your drive or just seriously derate it. So, basically a way you can save a little bit of money is you use a standard three-phase power supply or three-phase VFD and just use our single-phase power supply to replace the front end and just power the drive through the DC bus. By and large, I find that a lot of customers don't read the manual for the M3712, or if they do read the manual, they have a lot of questions about startup. Basically, we do require that there's a separate power coming in from the actual power terminals, L1 and L2, to what's powering the control board. The reason for this is we recommend using a reactor, but the power going to the control board needs to come from in front of the reactor. I'm not certain the reason for this, but basically it's just basically a reactance issue and what the control board needs. So the control board does need its own separate power source from the actual L1 and L2. The only issue is that the control board needs to be in phase with L1 and L2. If you don't, you will get an undervoltage fault right when you power on. If the terminals that are marked AC1 and AC2 are just flipped and just out of phase with L1 and L2. So The other issue I have upon the with the 36 or sorry, too many numbers, with the M3712 single phase power supply is that they'll start it up, they'll have the phases correct, but they won't see any voltage on the DC bus. That's basically because the M3712 does require an external enable. This can either be done with a jumper. I would say 99% of people just go for the jumper on those terminals for TV7-1 and TV7-2 on the control board, or else you can either control the M3712 through your PLC. But it seems that for most of our customers, they use a single phase power supply in locations that are remote or just very rural. So they mostly just want to be operating all the time as soon as they, give it power. So they usually just place that jumper in there on those terminals. So for me, I'm very visual, so I like seeing like all this, basically how the unit actually looks. This is an example of our M3712-H050, our 50 horsepower version of the M3712. The AC terminals are down here, L1 and L2. These should be connected to the power after a line reactor. And then we have our actual control board AC terminals up here. The sticker says AC1 and AC2. If you're looking at the board and what is written on the silk screen on the board, terminals are marked TB1-1 and TB1-2. Typically, I just tell customers AC1 and AC2 because that's just, it's big and they can see it just as soon as they open the cover. The AC1 needs to be the same phase as L1, and AC2 needs to be the same phase as L2. Otherwise, you will get that under voltage fault that I discussed about 2 slides ago. In order to get anything out on the DC terminals here, there needs to be an enable on this terminal here. This terminal is just a simple 4-pin terminal. The 2 terminals on the left, TB7-1 and TB7-2, these are enabled. And by and large, customers just put a simple wire here, simple little jumper, and the unit's enabled all the time, and it's ready to go. It's ready to perform and ready to give DC power to the drive. If the customer wants to have like a ready signal, a ready output, once the unit's pre-charged, this contactor will close, and this is just, unfortunately, yeah, this is a typo right there. But yeah, it's basically TB7-3 and TB7-4. Okay. Any questions about the M3712 single phase power supply? So the other power supply I'm going to put up here today is our M3713 SC. This is our 3-phase power supply that is able to has pre-charge. It's able to pre-charge quite a bit. Basically, you can pre-charge a lot just by phasing in. There's really no limit upon how much you can pre-charge. So if you do have a larger amount of capacitance on your DC bus, even with an addition of like a DC bus capacitance, this thing can pre-charge it. So it's pretty solid. So I don't really recall like any real issues we've had other than just enabling the unit. And just like the 3712 single phase, basically you just need to have either a jumper or a switch between the terminals. The terminals will be TB2-6 and TB2-7 on the control board. Here's this picture just zoomed in. Yeah, this is, yeah, so you just either need to have a jumper here and be able to enable it on these 2 terminals. Otherwise, you'll get nothing on DC bus. The terminals up here, these are basically the output terminals. Basically just telling you once pre-charge is complete, once the unit's ready to operate. By and large, most customers, all they need is a ready signal, and they're good to go. So yeah, the M3713, it's pretty solid, and other than enable, I haven't really gotten any issues on this unit ever. Basically, I'm going to talk a little bit about a whole different category of products. The basically we have a ride-through line which provides under voltage protection for your drive by basically storing energy um, in the voltage regulator, and then being able to output that energy onto the DC bus of your VFD, and basically sustain that VFD through like any seg, 50% seg for 2 seconds, or a full outage for a full second. But one of the optional things we have for our ride-throughs is the display. Um, the ride-throughs were made before the display, and as a result, we had to create a separate interface card, basically separate from the M3460. The M3460 had already been through UL as well as CE testing, and we didn't want to modify that after the fact to add the interface board. So we basically provide you with a separate interface module. We call it a module, even though the board is just contained inside this plastic case. This is the basically if you're going to mount it, this would be the front you'd see, and on the right hand side, if you're looking directly at this, you would see these terminals connections and these labels. And this is for the interface module, and this basically interprets the signals from the ride through and basically outputs it to the display. What we've had seen is that customers will just swap out these interface modules and displays, and just, they might have a seg system and they'll try and put it into a system that's meant for ultracaps or batteries, just depending what they have, and just thinking they were able to fix it. But honestly, just make the situation a little bit more complicated, because the way we test these interface boards is really we calibrate them for each individual ride through before they leave. That way we can understand the current, the voltage ratings, and they're calibrated just to read those. If you just swap those around, these calibration points change, and while it is possible to readjust this in the field, it's not easy, and we really strongly advise against changing the displays around. So we really do like pairing each interface module, display, and ride-through system if we can. We can go back and redo it. It's just it provides just a challenge, especially doing it over the phone. By and large, it's just almost quicker just to send it back into us if the boards have been swapped around, or if there's been changes made, and we can go and redo the calibrations here at Bonatron. These calibration menus are locked out. By locked out, I mean there's just a code that you'd have to enter on the arrow and the enter key and the exit key, and that will bring up the hidden menus for the calibration points. But we typically do not give this out. I mean, most customers, they just want to pull out of the box, connect it to their ride-through, and then be able to pull the information off the display itself, and not mess around with the calibration points. The other issue that we've seen with the display modules actually is because of the interface module. Here at the bottom, let me go back to the other slide. Here, this is the bottom of it, and basically you have the 24 volts power coming into here, the storage bus connections coming into here, the drive bus connections coming into here, and then the AC line voltage, where basically senses what the AC line voltage is doing, whether it's lost to phase or just going through a sag, comes into there. At the bottom of our older units, we since fixed this issue, but customers, when they're plugging in the connectors at the bottom, you can see how these do not have any sidewalls to these terminals here and here. So what we found is that more often than not, customers would think they would be connected just straight on with it, but they would actually be off, either left or right, and basically just we would get chaotic information. Either you'd have a storage bus fault, wouldn't be able to see any storage bus at all, or wouldn't be able to see any drive bus on the display, and that would cause issues. We've since fixed this by just simply adding sidewalls and plastic blocking right here. But if there's an earlier display that's out there in the world still, this could still potentially be an issue. So I'm just letting you guys know it is an issue we've heard about, and really one of the more common ones with our displays. But we've since addressed this. The next question I get as tech support is when stuff does not go well. Sorry, I love this photo. This is a photo of a customer who decided to try and check the terminals while there's still power going to them, and they gave themselves a nasty shock. Yeah, this unit was non-repairable and had to come back to us. So, yeah, just FYI, do not do that. So when troubleshooting does not work and I can't get them up and running over the phone, the next concern is actually about our repair process. If the unit needs to come back for repair or exchange or warranty, either myself or somebody else will give them an RMA number. The RMA number is basically just a reference number the Bonatron uses, and to allow the distributor to use. It's basically just used for tracking. So when a unit arrives, our receiving people can just place it on the right shelf and get it to the right person, the right technician. The technicians who take care of repairs, they're the same ones who check out the unit originally, and they're the ones who are most familiar with it, and they will go through it and basically evaluate it, typically within 24 to 48 hours of its arrival. In terms of money, we typically charge a $150 evaluation fee for repairs, but if there's additional labor time or parts that need to be added, we'll send them a quote and then add that on. But yeah, as far as repairs go, we typically do it at cost for parts and labor, and we don't try and nickel or dime our customers on repairs. Our goal is to try and get our customers up and running as quickly as possible. If a customer is down, we'll prioritize that and try and get them going. So as far as the next question, obviously, is when they need to send it in for warranty or credit. We still need the unit back for evaluation, making sure that there's no problems with either basically how it was wired in, or there's external damage, like it was dropped off a forklift or something like that, or it was just horribly miswired. In this case, this was a 230 volt capacitor, and it was wired to 480, so it blew a hole in the side. So after we evaluate the unit, we'll issue a credit memo to the company, and basically how we issue the credit is basically determined by our returns policy, and you can find our returns policy on the Bonatron website under the tab that's marked Contact. Okay, that basically concludes basically just our troubleshooting repairs process. Just basically the frequently asked questions that I really do get. If there's any questions about any other units that I haven't covered, I'll be happy to go over those. Or if there's more in-depth details about other units that that we've seen, feel free to ask me. Otherwise, this concludes my presentation. Thank you.